remember the type 1 integrals are the ones that have either negative infinity or positive infinity as the limits. This example, we're going to have negative infinity and positive infinity both as the limits. So we're going to take the integral of a function that goes from negative infinity to positive infinity. We're going to go both ways with it. So what's the first thing I need to do here? So we need to rewrite this so that we don't have infinity in our limits. And so we need to rewrite it using two separate limits. We need a limit for the negative infinity, and we need a separate one for the positive infinity, which means that we're going to break this integral up into two sections. We get to choose where we want to break it up. So we could choose a number like negative 3 billion, or we could choose a number like pi, or we could choose a more convenient number like 0. So what we're going to do is we're going to split this up at 0, write two separate integrals, and we're also going to write those integrals using limits. So here's what it's going to look like. We're going to have one variable approaching negative infinity, and we're going to take the integral from that variable to 0. And then we're going to have a different variable approaching positive infinity, and we're going to take the integral from 0 to that variable. Now, we can actually, it would be okay if I use t for both of them. In fact, in the definition or the theorem that I gave you yesterday, I did that. I'm going to avoid doing that, though, to avoid confusion. Because if I'm using a t here and I'm letting t approach negative infinity, I don't want to be tempted to use negative infinity when I'm doing this integral here. So I'm going to use two separate variables for this. To evaluate these integrals here, let's think about some of the methods we've done. Partial fraction decomposition won't work because the denominator won't factor. Substitution won't work because the derivative of the denominator is 2x, and I don't have any x's in the numerator. Integration by parts won't work because there's nothing to do. This is actually going to be an antiderivative that involves inverse trig. And so I'm going to give you a little hint here. So the derivative of the inverse tangent or the arctangent is 1 over 1 plus x squared. So what does that mean? So that means that to evaluate these integrals, we're going to use the inverse tangent. So the first one is going to be the limit as t approaches negative infinity of the arctangent from t to 0. And the second one's going to be the limit as s approaches positive infinity of the arctangent from 0 to s. And the reason that's arctangent is because the antiderivative of 1 over 1 plus x squared is arctangent. So evaluating each of those definite integrals, we're going to get the arctangent of 0 minus the arctangent of t as t approaches negative infinity, plus the arctangent of s minus the arctangent of 0 as s approaches positive infinity. Now, the 0 part, I think that's pretty easy. Anybody know what the arctangent of 0 is? Why? Why is it 0? Because the tangent of 0 is... So since we take the tangent of 0 to get this 0, then that's going to be 0. So both of those are going to go to 0. To do the other two, I want to look at what the inverse tangent function looks like. So you guys know what the tangent function looks like, I hope? Yeah, and it's periodic, but it has a bunch of vertical asymptotes. So the inverse, if we just flip the x and the y, is going to look, well, let me rewrite it here. I'm going to get rid of those zeros. The inverse is going to look something like that. Does that look familiar? What is this horizontal asymptote right here? What value is that? Where's the vertical asymptote for a tangent? Pi over 2, right? So since the vertical asymptotes for tangent are at pi over 2, the horizontal asymptotes are going to be at pi over 2. So this is going to be positive pi over 2. This is going to be negative pi over 2. So as t approaches negative infinity, what does the arctangent of t approach? Negative pi over 2. So we have the opposite of negative pi over 2 here, which is going to be pi over 2. And then as s approaches positive infinity, what does the arctangent of s approach? Pi over 2. So what we end up with is pi over 2 plus pi over 2, which is pi.